Introduction to Fluid Mechanics 1. Welcome to the topic, Introduction to Fluid Mechanics. Fluid mechanics is a division in applied mechanics related to the behavior of liquid or gas, which is either in rest or in motion. Learning objectives. At the end of this topic, you will be able to understand the dimensions and units of fluid mechanics, determine the physical properties of fluids such as specific gravity, specific weight, density, specific volume, viscosity, kinematic viscosity, Newton's law of viscosity, variation of viscosity with temperature, understand different types of fluids. Outcomes. By the end of this topic, you will be able to understand the concept of dimensions and units in fluid mechanics, know the physical properties of fluids and viscosity, kinematic viscosity, Newton's law of viscosity, variation of viscosity with temperature, understand types of fluids. Fluid mechanics. The science that deals with the behavior of fluid at rest, fluid statics, or in motion, fluid dynamics, and the interaction of fluids with solids or other fluids at the boundaries is known as fluid mechanics. Fluid, a substance in the liquid or gaseous state. Fundamentals of fluid mechanics. Mechanics. It is a physical science dealing with both stationary and moving bodies under the influence of forces. Statics. Mechanics deals with bodies at rest. Dynamics. Mechanics deals with bodies in motion. Definition of fluid. A fluid is defined as a substance that deforms continuously under the action of a shear stress, however small magnitude present. It means that a fluid deforms under very small shear stress, but a solid may not deform under small magnitude of the shear stress. By contrast, a solid deforms when a constant shear stress is applied, but its deformation does not continue with increasing time. In the figure shown, the deformation pattern of a solid and a fluid under the action of constant shear force is illustrated. Dimensions and units. The units are classified into two types. 1. Fundamental units. 2. Derived units. Fundamental units. All physical quantities are expressed in terms of length, L, mass, m, time, t. Derived units. It is expressed in terms of fundamental units, area A, velocity v, acceleration ac, pressure PR. System of units, 6 basic units. Derived units. Let's see the tables. Physical properties of fluid. Density or mass density. Density or mass density of a fluid is defined as the ratio of the mass of a fluid to its volume. Thus, mass per unit volume of a fluid is called density. It's denoted by the symbol ρ. The unit of mass density in SI unit is kilogram per cubic meter. That is, kg per meter cube. The density of liquids may be considered as a constant, while that of gases changes with the variation of pressure and temperature. Mathematically, mass density is written as specific weight or weight density. Specific weight or weight density of a fluid is the ratio between the weight of a fluid to its volume. Thus, weight per unit volume of a fluid is called weight density, and it is denoted by the symbol W. Thus, mathematically it is given as Specific volume. Specific volume of a fluid is defined as the volume of a fluid occupied by a unit mass or volume per unit mass of a fluid. Mathematically, it's expressed as relative density, specific gravity. Specific gravity is defined as the ratio of the weight density or density of a fluid to the weight density or density of a standard fluid. For liquids, the standard fluid is taken as water, and for gases, the standard fluid is taken as air. Specific gravity is also called relative density. It is dimensionless quantity and is denoted by the symbol S, mathematically as shown below. What is specific gravity? Specific gravity is simply the weight in grams or 1 cubic centimeter of a metal. Here are specific gravities and other properties of few more metals. Exercise 1. Calculate the specific weight, density, and specific gravity of 1 liter of a liquid which weighs 7 Newton. Exercise 2. 10 meter cube of mercury weighs 136 into 10 power 4 Newton. Calculate its specific weight, mass density, specific volume, and specific gravity.